Hey everyone, it's that math magician. On this video, we're going to see if we can prove that two triangles are congruent by using one of the conditions that we have for congruency. We're going to prove it this time using a flowchart. So let's go ahead and look at this example problem where I have two different triangles sort of connected at point R, and we want to see, are they congruent? Notice that I start with this triangle on the left side. We have QPR. And then we have this other triangle here on the right side that we could call STR. Those are the two triangles that we want to show if they're congruent or if they're not congruent. Again, when we start this process, all we really want to do is we want to look at the sides and we want to think about what ends up being equal to what. Are there any sides that are equal? Are there any angles that are equal? Because that's what we care about. Well, right off the bat, I hope it's very clear to all of you out there that we have this side here, QP, that has a length of 6 units. And then on this triangle, we have the side ST that also has a length of 6 units. So since both of those are equal to 6, we know that those sides are equal. So in our flow chart, we can mention that then. We can mention that the side QP is equal to the side ST. And the reason why they're equal is because they both equal 6 units. This is good. We have our first side that we've identified that they have in common. All right, let's keep looking for more sides. Maybe there are more sides than they're hiding. Well, I'm looking at these and I don't know, maybe QR and SR are equal. They might be. There's no markings on it though, right? I don't have any markings, no numbers. I don't know if they're equal, so we can't write that. We cannot write that QR equals SR because that would be assuming. And when we do proofs, we never want to assume. We can only go off the information we're given. So those aren't equal. And again, same reason why I can't write that PR and TR equal each other. I just don't have any information there. So I think it's going to be good for us to just move on from the sides and start focusing on angles because there's no more sides in common here. But I think when we move to angles, it's going to help us out because look, here at angle P, that's 120 degrees, and angle T is also 120 degrees. So we can say with great certainty then that the measure of angle P equals the measure of angle T. We are on a good foot right now. We have a side that's in common. We have one angle that's in common. We really just need one more angle, and we are golden. We can say that these are congruent. Now, looking at that diagram there, I don't see any other angles that are marked. Q and S, maybe they're equal, but again, no markings on it. I can't assume that they're equal. But what we can do though, is we can talk about what's happening here at R. Notice that we have these two different angles here, kind of touching each other at point R. Now, at point R, I hope you can see that we have two lines that are intersecting. And we need to recall that when we have two lines intersecting, we create angles, and more importantly, we create an angle relationship. Those are what we call vertical angles. And vertical angles are angles that are opposite of one another when lines intersect, and they are equal. So we can say now that this angle and this angle at R are equal to each other, but be careful in your flow chart. You cannot write that the measure of angle R equals the measure of angle R. And here's why. Look at point R. We have two different angles here. If I say angle R, I really don't know which one you're referring to. So that's why we can't say just angle R. What we're going to need to do is we're going to need to name it using 3 different letters. And I'll help you out. Here on this guy, we'll do the left side first. We could call this one PRQ. Notice I'm just tracing out that angle. PRQ. Use the 3 letters. We could say PRQ or we could say QRP. Doesn't matter. We just got to make sure we're using those 3 letters. So I'm going to use this. The measure of angle PRQ is going to equal the measure of angle, let's do the other one now, TRS. TRS. Or we could have done SRT. Okay, again though, we need to use 3 letters since there's 2 letters or 2 angles at that point R. So let's see, the measure of angle TRS. They are congruent. That's our other angle, and I think we just proved that these are congruent using angle, angle, side. So let's go ahead now and just write out our conclusion for our flow chart. And our conclusion is that triangle PQR is congruent to triangle TSR. And what did we use for this? Well, we used angle, angle, side. Or you could say side, angle, angle. Doesn't really matter. But again, remember, when we're attacking these problems, when we're trying to prove that triangles are congruent, we need to talk about what sides are equal and what angles are equal. If we can do that, then we can prove that they're congruent. It's that Math Magician, and I'll see you on the next video.